Welcome to Richplanet TV. I'm Richard D. Hall. Now on this show we have challenged the mainstream's version of history, and today we are going to talk about the history of physics and discuss claims that the holy grail of physics, the unified field theory, was discovered in the 18th century. Here to put forward his case is Roger Anderton. Welcome, Roger.
Thank you, Richard. Thanks for having me.
Okay, now just tell us a bit about yourself, Roger, and what first made you interested in physics?
Well, I think I've always been interested in physics. May go back to the time when Doctor Who scared me and I hid behind the settee. My career is, I basically had a try at doing A-level and physics and maths, and sort of like found it too difficult and didn't carry on there. Then I became a British telecom engineer.
Right.
And I got all the technical qualifications, like in telecommunications and computers and things like that. And you were doing things like physics and so forth. And so later on during my career, I went on to Open University and did physics and maths in Open University. And I was then looking for carrying on for, say, other things like postgraduate.
Right.
But I then found what I'd been taught wasn't correct.
Right. All right. So, and you call that the history that's taught in schools Whig history?
That's right. Yeah.
Just explain what Whig history means.
Whig was an old political party, and when they present history, they present it distorted as per their political bias, and so now it's a general term for a history which has got a biased point of view on it. And so it's really a false history. So if you want, and so when you go to university or get things like that, they teach you a false history of science, and they justify that by saying that makes it easier then to understand what they're trying to teach you from the theory and the experiments. You find out the true history is completely different to what they're teaching you when you're doing your science courses. And I have an example from this person here about
occultism and the atom, the curious story of isotopes.
Yeah, this historian has found that when you've gone back into the history of this subject, what they were doing, they were working from an occult philosophy in the early 20th century when they were doing isotopes. But because that was not respectable to believe in that sort of thing, they created a bogus history of what they were actually doing.
And you would contend that a lot of history taught in schools is Whig history?
It's just distorted of what really happened.
Right. Now, Newton and Einstein are two of the big figures in physics. Newton lived in the from 1643 to 1727. Einstein 1879 to 1955. Yeah. Now, you think that these two guys were probably less important than people have made them out to be, and that there are people who've been almost forgotten about, such as Tesla, for example. Yeah,
that's right. Tesla was very impressive. Before Einstein suddenly became famous, a lot of emphasis was on Tesla, what Tesla was doing, and sort of like Einstein, sort of when he became famous, sort of like overshadowed all the amazing things that Tesla was doing.
Right.
In his discoveries, you've got discoveries in Tesla which sort of like pretty astounding if you really believe them, but they try to divert onto Einstein.
And in one of your lectures you show a film, a modern day film where Tesla is portrayed. What's the name of that film, Roger?
Prestige.
Right, and just tell us.
There's a good film, but it's only fantasy. It has David Barry portraying Tesla, and there's several. Well, David Barry is quite amazing actor, and he's done a film, what's The Man Who Fell to Earth, and I kind of think the way he portrayed Tesla was sort of like an alien as well, because there's an amazing scene where he's walking through lightning, and that is kind of like an alien coming towards you.
Right.
And Tesla was doing all these amazing things with electricity, and he is pretty much the person who invented the AC power system, and he should be more recognised than what he really is.
Right. They're trying to portray him as some sort of fantasy.
Well, in the film, it's
a science fiction figure.
Yeah. But if you go into conspiracy side of things, there are things like the Philadelphia experiment, and they say, oh, Tesla technology was used for that sort of thing. So you get sucked into all these sort of like diversions,
right?
Which is might be true, may or may not be true, but the theory that Tesla was working from is sort of like disappeared. Yeah.
I mean, I think if you look at the things that Tesla invented, stroke discovered,
yeah,
and their application in the real world, I would say they far outshine anything that Einstein came up with.
I would have thought so.
For example, you mentioned the polyphase motor generator and electricity grid system, and many other devices as well.
Yeah.
Einstein, well, would you need relativity if you were going to get into space, do you think?
Well, according to, if you believe in Einstein's relativity, it is very important to you for astronomy and so forth. And he did make these papers on the photoelectric effect, which is supposed to be used, helped in laser technology and so forth. So his theories are supposed to be very important for science as used, but it is kind of bogus in a way, because I don't reckon they're really properly using a lot of Einstein stuff.
Right, and you think that Einstein got certain things wrong as well?
Yeah. Physics, it's been heavily influenced by what Einstein has thought, and he's changed hundreds of things from what it was originally, and so it takes a very long amount of effort to actually study all that. But in conjunction with that 100 years or so worth of Einstein, there's been 100 years worth of criticism on pretty much everything that Einstein did.
Right.
And so it takes a lot of study just to look at the alternative point of view to Einstein. And I've got here what is called the
95 years of criticism of the special theory of relativity, 1908 to 2003.
Yeah.
Right.
And so they're documenting all the people criticising Einstein, and you've got the catalogue of the topics, if you can see it. It's all these topics of where they think the areas are.
Right.
And people have looked at each of these things. Einstein's influenced each of these things in his way, and people have looked at what Einstein's done, influenced, and said, oh, there's an error. And so when they count the number of errors, people were claiming it goes into hundreds of hundreds of claims of error. So that's how big Einstein is. People have claimed lots of errors in Einstein's work.
Right. Let's come on to the unified field theory of physics. I'll just give you my sort of broad understanding of what that is. We've got forces in nature, one of which is gravitation. Another force is generated through magnetics or electromagnetic phenomenon, and then you've got forces inside atoms, which is usually termed the strong and weak nuclear forces. So you've got forces appearing in nature which shape the world, and it is believed that there's one underlying phenomenon which connects all of them together, and that is the unified field theory of physics. So, which, if you speak to a modern day physicist, they will say, well, that hasn't been discovered yet. Would you go along with that?
Well, that's roughly it. They've got several candidates which they claim will unify the forces, and the main one I think at the moment is they call it superstring theory, but there's other ones like quantum gravity, quantum loop theory. And so they've got these proposals for unifying the forces, and they've got the three forces like the strong, the weak, and the electromagnetic forces. They've got them unified in the grand unified theory, I think you call it. The problem they find is trying to unify gravity to that, because you're trying to unify Einstein's relativity with quantum physics.
Right. So when you say they've got them unified, there's one equation with all of the different terms in there that represent each force. Would you say?
Well, it'd be complicated equations, with matrices and things.
Right. Yeah. All right.
Keep adding extra bits.
Right. One character that we haven't mentioned yet, Roger, is Boscovich, who lived between 1711 and 1787. And you actually think that Einstein plagiarized some of his discoveries? Or is that too strong a word?
It's probably too strong a word. I'm finding it.
Got his ideas from Boscovich.
I'm finding it very difficult to tie in Boscovich to Einstein. How much did Einstein know about Boscovich? I've got people who were working on the unified field theory with Einstein, because Einstein had a big fight with the establishment over quantum physics. He argued with them that quantum physics was wrong. And while they went off to carry on with quantum physics, he then went off to look for the unified field theory. And those people who were working on the unified field theory were sort of like ignored by the people who were working on the quantum physics. And so I've got the history of these people who are working on the unified field theory, and the people who are working on that, they some of them were aware of Boscovich. So it is tied into Einstein's quest for the unified field theory. It's sort of like, it's to the mainstream physics. It's forgotten history.
Right.
It is known in the history of physics department
Boscovich
as an obscure subject. Some people in the history of physics do know about it, but they're a small number of them, and this information doesn't really get sent over to the working physicist people. There's no communication breakdown in departments.
Right.
The history department thinks if it was important, the physicists would ask me about it, and the physicists think I'm not interested in history.
I'm talking to Roger Anderson about the history of physics, and in particular Boscovich. We've got a picture of Boscovich on the screen there. Just tell us a little bit about him, Roger.
Yeah, in the 18th century, the Catholic Church was trying to recover from having persecuted Galileo, but they had the priests, the Catholic priests, some of them were still looking into the science issues of what Galileo was talking about, and so Boscovich is one of the top men they had looking into this issue. And I think this is supposed to be him, but he was looking at Newton's physics, and so he was what he considered to be the first Newtonian on the continent of Europe, and he advocated Newtonian physics, and a large part due to his influence, he managed to get the Catholic Church in the European countries to accept Newtonian physics.
Right.
After having banned that sort of physics with Galileo.
His life overlapped a few years with Newton.
I think so, yeah.
So, but he's certainly after Newton.
Yeah. The conflict at the time that when Newton died, which was left, was they had a conflict between Newton and Leibniz over physics. So you had people, and you also had Newton not having a complete theory. It didn't unify everything, and so Boscovich was into combining the ideas of Newton and the ideas of Leibniz and making a unified theory.
Right.
Hence why this is a unified theory. And what he was talking about was a sphere of influence around objects, which we can interpret as a field. So he was talking about a field influencing other objects. So it's a unified field he was talking about.
Right.
It's the first unified field theory I know about.
All right. Do you want to expand on that a little bit, Roger?
What my emphasis has been upon is translating his work, because most of his work has not been.
Yeah. This is a booklet that Roger has translated.
This is a chemist in Serbia who has worked on Boscovich's theory, and he's very impressive. He's got a lot of qualifications.
And you've translated.
He's written 60 papers or so on Boscovich.
And what's his name?
Science Journal. He's Dragoslav Stokovich. So this is modern work on Boscovich's theory.
Right, and this guy's alive today. Right.
And he sort of like I think he's advocating that it's a unified theory of physics as well, because he ties it into quantum physics. He's done the work.
And you've translated his document into English. He's saying that there is a field of influence around objects or matter, and that's characterized by this graph of his.
The graph,
which is a force distance graph.
That is the force. That's how he's displaying the force between particles. There's an attractive force and there's a repulsive force between particles, and it's what we now say is a field. So there's a field for repulsive force and a field for an attractive force. And with Newton, he was only considering gravity as being attractive.
Right.
So with Boscovich, you've got more than just an attractive force,
yes.
you've got a repulsive side to it.
So if we look at that graph there on the screen, we see that the vertical axis is force and the horizontal axis is distance, yes?
Yeah.
So what that's saying is, as we move further away, out say from the centre of a particle, the force will pull you back, then it'll push you away. As you go further away, it'll pull you back again. As you go further away, it'll push you out again. So it's varying. So that would lead one to believe that there are certain areas that you'll be forced into, i.e., well, of the around an atom.
Yeah, that's right.
So is this defining the orbits of an atom then? This graph?
Yeah, Niels Bohr was working from Boscovich's theory when he constructed the hydrogen atom. He was considering electrons going around the nucleus, and there was allowed and forbidden orbits. There was places where the forces was balanced, and there's places where the forces weren't balanced. And where they were balanced, there was an allowed orbit of the electron around the atom, or the atom's nucleus. And when it was not in that region of area space, it would be unbalanced force, and so it would either be pushed further in or would be pushed further out. Sort of forbidden areas around. That's the quantum levels of the atom.
And you can have so many on each level. If I remember from my chemistry, 2 and then 8, and then it gets a bit weird.
Yeah, that is a bit more on top of it from Pauli's exclusion principle and things, I think. But the basic idea of allowed and forbidden orbits around the nucleus is coming from Boscovich with his force theory.
So Bohr then, who came up with this different levels of electrons in the atom, do you think he got his theory from Boscovich?
Yeah, he did. He was working for Boscovich's theory.
Right. So why is it called the Bohr atom rather than the Boscovich atom then? Because is this all part of the Whig history thing?
You caught me. I don't know why they do that. If you're being more accurate, you probably call it the Bohr-Boscovich atom, but they've just called it the Bohr atom.
Right. All right. Well, here's a question then, Roger. So, if we come outside of the area of an atom and we get to, say, electromagnetic or gravitational forces, does Boscovich include gravity, for example?
Yes, gravity comes into it.
So can you show us that on? I mean, is that part of that same graph, or is that a different thing?
I'm not really got it shown on the diagram, but I'm in contact with loads of people, and one of the people is working out what is the characteristics of the graph. So I've got this person who's Augustus Prince, who's retired from Brookhaven National Laboratory, and he's looking into complicated issues like that.
Right. Okay.
So that should be hopefully published soon. It's supposed to have been coming out from a conference I attended. So
you would like to see Boscovich named as one of the pillars of physics in physics education, would you?
He was.
He was. Yeah.
I mean, the Catholic Church says that Boscovich is the father of atomic theory.
Right.
And he was the theory which the atomic physicists were using during the Manhattan Project.
Right. Right. Rather than Einstein.
Yes, I think so.
Because you were telling me earlier on that the people who were developing the atomic bomb didn't really get on with Einstein. I mean, wasn't Einstein a bit of a pacifist? Not that there's anything wrong with that, but
during World War I, Einstein was a pacifist. It's just, he wasn't. That's why the other Germans fell out with him. He wasn't patriotic, but during World War II, he sort of like gave up pacifism and decided you had to fight Hitler.
Right.
So he changed his mind on that.
Right. Okay.
But he wasn't involved in the Manhattan Project, which is the atom bomb project.
Right.
Other than writing a letter to the president saying, look into building the atom bomb, because he was afraid that Hitler was going to try to build one. Most of Boscovich's work hasn't been translated into English, so I'm trying to translate it. And you get, this is the Latin, so that bit there is using the word quantum, and quantum is a Latin word, so he is saying there quantum physics. But if you're looking at what the word quantum means in Latin, it comes out roughly meaning as much as. So it is a bit difficult to understand what is meant there. From a modern perspective, we would think of quantum physics, but as much as physics allows, he's saying. As much as physics allows, he's talking about Newton demonstrating something, a proposition, and it says as much as physics allows. So quantum physics is coming from the writing of Boscovich in the 18th century.
I'm talking to Roger Anderton about the history of physics. Now, Roger just is going to show us a clip from a lecture given by Rupert Sheldrake. Now, this lecture, you said to me, was banned, Roger.
Yeah.
And was because Sheldrake does kind of stray into the area of physics in his work, doesn't he? Because he's really trying to get to the nub of what's really going on in biology, and that leads him to physics. So I gather a physicist complained at what he'd said in this lecture.
Well, a scientist, it might have been a physicist.
Right. So it was taken off?
No, they banned it from the normal TED Talks.
Right.
TED is a collection of talks on by
Bill Gates.
Bill Gates. I have a lot of people on, and it's supposed to be promoting public understanding of science and so forth.
Yeah.
And there's too many protests about this. Sheldrake says lots of interesting things, and this is the bit I wanted to emphasise.
I want to spend a few moments on the constants of nature too, because these are again assumed to be constant. Things like the gravitational constant, the speed of light, are called the fundamental constants. Are they really constant? Well, when I got interested in this question, I tried to find out. They're given in physics handbooks. Handbooks of physics list the existing fundamental constants, tell you their value. But I wanted to see if they'd changed, so I got the old volumes of physical handbooks. I went to the Patent Office Library here in London, and they're the only place I could find that kept the old volumes. Normally people throw them away when the new values come out. They throw away the old ones. When I did this, I found that the speed of light dropped between 1928 and 1945 by about 20 kilometers per second. It's a huge drop because they're given with errors of only fractions of decimal points of error. And yet, all over the world, it dropped, and they were all getting values very similar to each other with tiny errors. And then in 1945, it went up, 48, it went up again. And then people started getting very similar values again. I was very intrigued by this, and I couldn't make sense of it. So I went to see the head of metrology at the National Physical Laboratory in Teddington.